Continuity part 3. Question number 1. Examine the continuity of function f at x equal to 0. So function is given as fx equal to modulus sin x divided by x when x does not equal to 0, and it is 1 when x equal to 0. Let's consider LHL. Limit x tends to 0 minus modulus sin x divided by x. Let x equal to 0 minus h, where h is tending to 0. So we write it limit h tends to 0, and we put x equal to 0 minus h here. So sine 0 minus h divided by 0 minus h. So here it becomes sine minus sine h modulus divided by minus h. Sine h, limit is h tends to 0, limit h tends to 0, sine h upon minus h, which will give minus 1. Now RHL, limit x tends to 0 plus function is same, sine x modulus divided by x. Here we put x equal to 0 plus h, where h is very small, h tends to 0. So our question becomes limit h tends to 0, and in place of x we write given this is modulus sine 0 plus h divided by 0 plus h, which becomes sine h modulus divided by h of sine h upon h, which will give 1. Since LHL does not equal to RHL, so function is not continuous. The function is discontinuous. Consider next question. Examine the continuity of function f at x equal to minus 3 and at x equal to 3. So first we consider at x equal to minus 3. LHL, limit x tends to minus 3 minus, then function is modulus x plus 3. Here we put x equal to minus 3 minus h. So where h tends to 0, so we write it limit h tends to 0. In place of x, we write minus of 3 minus h within bracket and outside bracket plus 3. So it will become limit h tends to 0, 3 minus h plus 3, which will give 6. Now we consider RHL. For RHL, we take this value. So limit x tends to minus 3 plus, and function is minus 2h. So it will become minus 2. But before that, let's assume x equal to minus 3 plus h. So we write it limit h tends to 0. In place of x, we write minus 3 plus h. So it will become minus 2 times minus 3 plus h. So it will become 6 plus h, and we put h equal to 0, we get 6. Since LHL equal to RHL, so function will be continuous at x equal to minus 3. Now let's consider it at x equal to 3. So we write at x equal to 3. LHL limit x tends to 3 minus, then function will be this minus 2x. Let x equal to 3 minus h, where h tends to 0. So this becomes limit h tends to 0 and minus 2 in place of x. We write 3 minus h. So it will become minus 6 plus 2h, limit h tends to 0. So it will be minus 6. Now we consider RHL. So limit h tends to 0. And this time function is 6x plus 2. Sorry, limit x tends to 3 plus function is 6x plus 2. If we take x equal to 3 plus h, where h tends to 0, so it becomes limit h tends to 0 and we write 6 within bracket 3 plus h plus 2. Then we put value of h, so we get 20. Here LHL is minus 6 and RHL is 20, so function is not continuous. Let's go to next question. We are given examine the continuity of f at x equal to a, where function is given as modulus x minus a upon x minus a, where x does not equal to a. It means we have to take LHL and RHL from here. So let's consider LHL. So limit x tends to a minus x minus a modulus divided by x minus a. Let x equal to a minus h, where h tends to 0. So it will become limit h tends to 0. And in place of x, we write a minus h minus a divided by a minus h minus a. So from here, minus h divided by minus h. Modulus of minus h will become h divided by minus h, which will give minus 1. Now we consider RHL. Limit x tends to a plus, then we write same function because it is not equal. So x minus a divided by x plus a, in numerator it is modulus, and let x equal to a plus h, where h tends to 0. So our question becomes limit h tends to 0, and in place of x we write a plus h minus a divided by a plus h, and in denominator it is not plus a, it is minus a. It is minus a. So a plus h minus b. So from here a will cancel out, from here a will cancel out, and the modulus h is h divided by h. So this time we are getting 1. In LHL we have got minus 1. In RHL we have got 1, and value of function is 1. So all three are not equal. So we say that function is discontinuous. Now let's consider next question. Examine the continuity of greatest integer function. So we are given fx equal to greatest integer function. Suppose we have to check limit at x equal to b. So limit x tends to a minus and greatest integer. Now let x equal to a minus h. So this will become limit h tends to 0, and in place of x we write a minus h. The property of greatest integer is that, suppose this is 0, this is 1 negative, this is minus 2, Similarly, other numbers here, suppose this is 1, this is 2, this is 3, etc. And suppose we are here. So suppose we have 2.5 greatest integer, then answer will be the previous whole number. So answer will be 2. Similarly, suppose we are here, say negative 0.5, and if we take its greatest integer 0.5, then it will become -1. So here a, we can assume any number. Suppose a is 1, then a minus h, greatest integer, will be previous number. It means this will become a minus 1. Similarly, suppose we consider RHL. This was LHL. Now RHL. Suppose limit x tends to a plus and greatest integer. So again, same rule. Suppose we take x equal to a plus h, means slightly greater value, then greatest integer will fall back, means it will be previous whole number. Suppose this is suppose a, or this is a, suppose this is a plus 1, and we are choosing this value here, a plus h. So its greatest integer will fall back to previous whole number. So here this will give limit h tends to 0, a plus h. So this h portion will be removed and answer will be a. So what we have observed in case of LHF, it is reduced by 1. In case of RHL, we have got just that value. So these two are not equal, hence function is not continuous. Now let's consider question number 5. Find all points of discontinuity of f defined by fx equal to modulus x minus modulus x plus 1. Let's consider solution. So we assume gx equal to modulus x and say ux equal to modulus x plus 1. Now, gx equal to modulus x is an absolute valued function. And it is known that all absolute valued functions are continuous. So it is continuous. Similarly, ux, which is modulus x plus 1, is also an absolute valued function. Is an absolute valued function. So it will also be continuous. Continuous function. And difference of two continuous functions is a continuous function. Functions is a continuous function. Hence, fx equal to modulus x minus modulus x plus 1 is also a continuous function. Thank you for watching.